Hey physics class, how's it going? We got new week, we got some new topics as well. We've been doing energy for 2 weeks. Energy is not going exactly away, but we're adding another topic into our physics repertoire here. We're going to talk about momentum and then how impulse also has to kind of join in with momentum. So energy is going to make its way back, just like you've always seen kinematics kind of make its way in, as well as dynamics have made its way back into the energy unit. Energy is going to stick around as well. But let's look at momentum. You may have done some of this in grade 10, possibly, depending on who you had. I know it kind of works on the same idea as some free body diagrams. We're going to be using a lot of force, basically, in looking at our momentum. So what is momentum? What is impulse? Let's start with momentum. I have my 3 new formulas for this week, kind of right here, and they'll be in your formula sheet as well. Momentum is a lowercase p. All right, so again, I don't get to pick what they are. They've been given and chosen already, but lowercase p is our momentum. And actually a really, really simple formula for momentum. Basically, it's just the mass multiplied by velocity, okay? And so momentum is basically just how much, again, when you think of momentum, I hope you think of like a truck moving at a very fast speed. It's hard to slow that down. Momentum is measured in, okay, kilograms meters per second, which is just mass kilograms, velocity meters per second. Unfortunately, there's no nice little unit. I really wish there was, but it's that, kilograms meters per second. And so again, momentum is like basically how heavy something is and how fast is it going. So it's how hard is it to slow down, or how hard is it to speed that thing up. Again, if you have a very large mass, it's hard to get that thing moving very fast, okay? But how much momentum something has is their mass multiplied by velocity. Now, impulse ties in with momentum a lot. So I kind of want to look back at our energy. So we had energy here, we had kinetic energy and potential energy. What was work? Well, work was the change of energy, and it had its own little formula. Like if there was a change of energy, that means work was done, and then you could also kind of figure out some stuff here. Impulse is the same thing as work was, but impulse is the same to momentum. Impulse is a change in momentum. So if I apply a force, and then for this one it's time. If I apply a force over a certain amount of time, I'm giving an impulse and I'm changing something's momentum. Okay? So in grade 10 I do this little activity where I tie a string around a certain student, and then I'm going to try and get them to the end of the hallway. Okay? If I apply a small amount of force, it's going to take a long time to get that student all the way to the end of the hallway. If I apply a bigger force, it's going to take less time. So I'm going to have the same momentum change because they're going from one spot to another, and relatively at the end they have the same velocity. But basically, again, there's our way to look at impulse is it's the change in momentum. So anytime we have a change in momentum, that impulse, like whatever that change is also equal to the impulse. Okay? We can also look at impulse as its own standalone formula, kind of what I just referenced to. It's how much force. Again, it's always going to be a net force. If 2 things are pushing in opposite directions, which one's winning and by how much? So that's still a net force. And then time. Again, how long are you applying this force? Okay. If I am pushing a box and if I apply force and only for a short time, it's going to get only to a certain velocity. If I apply that force for a long time, it can get to it faster. Kind of think of it as like the gas on your actual car, in the sense of like if you step on the gas and only step on it for a little bit, you're only going to get it to a certain speed. Your car can only get to a certain velocity. If you step on that gas and leave it there more and more and more and more, your car is continuously going to get faster and faster and faster and faster. And that's the thing, is the longer you have the more impulse you have because of the bigger time, the more change momentum. And your car's not changing in weight anytime soon. So the only thing that can change if mass stays the same is your velocity, okay? And so that's kind of our intro into what is momentum, what is impulse, how do they actually connect? They connect kind of similar to energy and work in that same way, where impulse is the change in momentum. We can kind of use these 3 interconnectedly. All right, so I have 3 videos here that I'm going to be kind of going over after this one. They're all going to be example questions. I don't want to say easier this week, but I went with the basics of momentum first before we get to some of the harder and bigger questions. Either we had to have a harder week this week and then less next week, or maybe a little easier week this one, and then a more full week next week. So this one hopefully is not going to be too bad. All we're looking at is, can you calculate momentum? Can you calculate impulse? And then also, what does a change in momentum mean? Okay, and I'll go over change of momentum in for sure one of my videos. So the next 3 videos, we're gonna go over questions from, there's 2 practice sheets in your actual file folder. There's practice sheet number 1, which has an answer key. Practice sheet number 2 has a little answer key that just gives you, not exactly the same, but it gives you the answers in just a little bit different format. But there's 2 practice sheets, 2 answer keys, and I'm gonna be doing, I don't know, 8 kind of questions out of all of them in our 3 little videos. So hope it goes well. I'll talk to you guys soon. Thanks.